Hello everyone. In this video, we're picking it up in our section 2.3 lecture notes that I distributed in class, and we're starting at on page 3, right? So this is the second video on section 2.3 lecture notes. In this part of your notes, top 2.3, what we're going to learn is given the quadrant that an angle theta lies in, we can determine for each of the 6 trigonometric functions whether the value of the trigonometric function is positive or whether it's negative. We're not going to know maybe what the precise value of the trigonometric function is, but we'll know whether it's positive or negative depending upon what quadrant the angle theta lies. Okay? So top of page 3, right, the angle theta lies in the quadrant containing the terminal side of the angle. And so here I have 3 examples of angle drawn in standard position in the coordinate plane. And remember, when an angle is drawn in standard position in the coordinate plane, the vertex is at the origin, the positive side, or the initial side of the angle is along the positive x-axis, and then the terminal side is somewhere in the coordinate plane. So here we have the angle theta equals 17 pi over 4 radians, right? So this is the terminal side of the angle, and you can see the terminal side of the angle is in quadrant 1. So in the first quadrant. So we say the angle theta lies in the first quadrant. Okay. In this third example, we have the graph of the angle theta equals 5 pi over 4. Right. So here's the terminal side of that angle. And the terminal side is contained in the third quadrant of the coordinate plane. So we say the angle theta lies in quadrant 3, in the third quadrant. In this middle example, we have the graph of theta equals 5 pi radians. So again, this is the initial side going to the right, and this is the terminal side going to the left. And we talked about this in our, I think it's our section 2.1 notes, maybe it was 2.2. I think it was 2.2. If the terminal side is on an axis, the x-axis or the y-axis, the angle doesn't lie in either quadrant. We call that a quadrantal angle. So this theta equals 5 pi is an example of a quadrantal angle because the terminal side lies on the x-axis, okay? So we're going to be dealing with the first example and the third example, right, where the terminal side doesn't lie on an axis, but it's somewhere in the coordinate plane besides on an axis, okay? So down below the rectangle, right, it says if we know in which quadrant the angle theta lies, then we can determine the signs of the trigonometric functions of theta. So if we know what quadrant contains the angle theta, we know whether the cosine function is positive or negative, whether the sine function is positive or negative, whether the tangent function is positive or negative, and so forth. Okay? So we're going to consider the sine function, the cosine function, and the tangent function. And to determine whether these trigonometric functions are positive or negative for an angle, for given an angle in a quadrant, we're going to reference the unit circle. Okay? And remember, for every angle in the unit circle, the value of the sine function is the first coordinate on the unit circle, and the value of the cosine function is the second coordinate, right, the y coordinate. So let's consider an angle in quadrant 1. So let me draw in the coordinate plane over here on the right hand side an angle in quadrant 1. Okay? So here's theta in quadrant 1. Well, if you look at the coordinate plane, or if you look at the unit circle, okay, you know that cosine theta for any angle theta on the unit circle is equal to the x coordinate. Okay? And sine theta for any angle on the unit circle is equal to the y coordinate. And tangent theta is equal to the y coordinate divided by the x coordinate. Okay? So we're just considering these three trig functions in our discussion over here on the right hand side. Well, for any angle in the first quadrant, both the x coordinate and the y coordinate for the points on the unit circle are positive. So that means, right, cosine theta is equal to x. So that means the cosine of any angle in the first quadrant is positive. The y coordinates are all positive, so the sine of any angle in the first quadrant is positive. And the tangent of any angle in the first quadrant is positive. So I have written in the first quadrant over here on the right hand side in the coordinate plane, all three are positive. Okay? Sine, cosine, and tangent are all positive for angles in the first quadrant. For angles in the second quadrant, so here's an example of an angle theta in the second quadrant. Okay. Looking at the unit circle over here, just looking at these angles in the second quadrant on the unit circle, we see that the x coordinate for each point on the unit circle is negative and the y coordinate is positive. So since cosine theta is equal to the x coordinate, that means the cosine function is negative for any angle in the second quadrant. The sine function for any angle in the second quadrant is positive because all the y coordinates are positive. So x is negative, y is positive, and positive over negative is negative. So that means the tangent function is negative for any angle in the second quadrant. So I have written here in the coordinate plane over here, only the sine function is positive. Of these three, only the sine function is positive. Cosine and tangent are both negative. Well, now let's draw an angle in the third quadrant. Here's my angle theta in the third quadrant. Okay. Well, looking at these angles in the coordinate plane, or these angles on the unit circle, in the third quadrant, right? You can see that each point associated with those angles, the x coordinate is negative and the y coordinate is negative. So since the x coordinate is negative for all those angles, cosine theta is the value of cosine theta is negative because it's equal to x. And sine theta is negative because it's equal to y. But tangent theta is positive because y is negative, x is negative, and negative over negative is positive. So the tangent function for any angle in the third quadrant has a positive value. And so I have written over here in our coordinate plane in quadrant 3 that of these three, sine, cosine, and tangent, only the tangent function is positive. Sine and cosine are both negative. And then lastly, let's draw an angle in quadrant 4. And using the unit circle over here on the left, right, we have these three angles that are in quadrant 4. And the x coordinate for each angle in the fourth quadrant here is positive, and the y coordinate for each angle in the fourth quadrant over here is negative. So that means for any angle in the fourth quadrant, the cosine of that angle, which is equal to the x coordinate, is positive. the sine of that angle in the fourth quadrant, for any angle in the fourth quadrant, is negative because all the y coordinates are negative. The tangent of that angle, which is equal to y over x, well, y is negative, x is positive, negative over positive is negative. So that means the tangent function has a negative value for any angle in the fourth quadrant. So only cosine is positive of these three trig functions. Only cosine has a positive value for angles in the fourth quadrant. And so I have written over here in the coordinate plane, only cosine is positive. So all three, sine, cosine, and tangent, all three of those trig functions have a positive value if the angle's in the first quadrant. Only sine is positive in the second. Only tangent is positive in the third. And only cosine is positive in the fourth. So you notice I have A underlined in all are positive. S underlined and only sine is positive. T is underlined and only tangent is positive. And only cosine is, and C is underlined and only cosine is positive in quadrant 4. So how do we remember which of these three trig functions is positive in each of these 4 quadrants? A, S, T, C. We use those letters of the alphabet to form the acronym All Students Take Calculus. Start here in quadrant 1 and go around in counterclockwise direction. All, A in all stands for all three, sine, cosine, and tangent. S in students stands for sine in quadrant 2. T in take stands for tangent in quadrant 3. And C in calculus stands for cosine in quadrant 4. So that's one way to remember which of these three trigonometric functions is positive when the angle is in one of those quadrants. An alternative acronym to All Students Take Calculus is some students remember a smart trig class. Okay? So you know an acronym is just some wording to help you remember something. Okay? All right. So let's use this information to solve the exercise at the top of page 4. We're given 2 pieces of information, and we have to determine whether we have to determine what angle we have to determine what quadrant the angle theta lies in. And so the 2 pieces we're given is that the sine of the angle theta is less than 0, and you know any value that is less than 0 is negative. And the second piece of information we're given is that the cosine of the angle theta is greater than 0. And you know any number that's greater than 0 is positive. So given those 2 pieces of information, what quadrant does the angle theta lie in? Quadrant 1, quadrant 2, quadrant 3, or quadrant 4? Well, from the definition of the 6 trig functions of theta, you know that the cotangent of the angle theta is equal to x over y. Cotangent's the reciprocal of tangent, right? Tangent theta is equal to y over x. So if x over y is a positive number, then the reciprocal of that fraction, y over x, has to be positive, right? If I have the number 2/3, you know that's a positive number. And so the reciprocal of that number is 3/2, and that's a positive number. So the reciprocal of a positive number is a positive number. So if cotangent is positive greater than 0, then it must be true that the tangent of the angle 0 has to be positive, has to be greater than 0. Okay. So we can conclude that the tangent function is positive, has a positive value in this example because the cotangent function has a positive value in this example. Well, if the tangent function has a positive value in this example, what quadrants must the angle theta come from? Well, the tangent function is positive in quadrant 1. So theta could come from quadrant 1. And from the previous page, tangent is negative. Only sine is positive in quadrant 2, and only cosine is positive in quadrant 4, but only tangent is positive in quadrant 3. So the angle theta could be in quadrant 3. So just based on the tangent function having a positive value, the angle theta has to either come from quadrant 1 or quadrant 3. Okay. Then we have the second piece of information. The sine function is negative for this angle. So if the sine function is negative, what quadrant must theta come from? Right? What possible quadrants must theta come from? Well, sine's positive in quadrant 1. It's positive from the previous page. It's positive in quadrant 2. Only tangent is positive in quadrant 3. So sine's negative in quadrant 3. So theta, based on the sine function being negative, could be in quadrant 3. But quadrant 4, only cosine is positive, sine is negative in quadrant 3, so theta could come from quadrant 4 as well. So based on this first piece of information that the sine function is the value of the sine function is negative, means theta must lie in quadrant 3 or quadrant 4. In the second piece of information, the value of the cotangent function is positive, means theta must lie in either quadrant 1 or quadrant 3. Well, what quadrant must theta lie in to satisfy both pieces of information? Well, only if theta lies in quadrant 3 does it satisfy both pieces of information. And so we deduce, using deductive reasoning, that theta lies in quadrant 3. And we're done, okay? We figured out what quadrant the angle theta must lie in given these two pieces of information. Alrighty? All right, in the next rectangle, you're given some fundamental identities of the trigonometric functions. These have to be memorized for the exam. There's no formula sheet on exam 1. All formulas must be memorized. Okay? So we have what are called fundamental identities. And all of these identities can be derived from the definition of the 6 trigonometric functions. Okay. From the unit circle, cosine theta is equal to the x-coordinate, sine theta is equal to the y-coordinate, and tangent theta is equal to y over x. Right, that's from the definition of the 6 trig functions of theta. Well, let's just kind of go through these. Tangent theta over here, we know is equal to y over x. Well, y is equal to sine theta from our definition, trig functions, and x is equal to cosine theta. So using the definition that tangent theta is equal to y over x, substituting for y and x, we have tangent theta is equal to sine theta over cosine theta. That's where that identity comes from. And the same is true for cotangent theta over here. Cotangent theta, from the definition of the trig functions, is equal to x over y. And when we put in cosine theta in for x and sine theta for y, we have cotangent theta is equal to cosine over sine. Okay? Next we have the 3 reciprocal identities. And from the definition of the 6 trig functions, right, cosecant theta is the reciprocal of sine, right? It's equal to 1 over y. Right? Sine is equal to y. Cosecant is equal to 1 over y. And when I replace y with sine theta, I have 1 over sine theta. So cosecant theta is equal to 1 over sine theta. And similarly with secant theta, from the definition of the trig functions, it's equal to 1 over x. Well, x is equal to cosine theta. So when I replace x with cosine theta, I have 1 over cosine theta. And in the previous page, right, in doing the example at the top of page 4, right, we pointed out that cotangent is equal to x over y, which is the reciprocal of tangent. And so cotangent theta can be shown to be just equal to 1 over tangent theta. Okay. Then we have the 3 Pythagorean identities. And you know that the equation of the unit circle on the previous page, right? The unit circle has a radius of 1. Well, the equation for that unit circle on the previous page is y squared plus x squared is equal to 1. That's the equation of the unit circle on the previous page, right? So if I replace y with sine theta, right, then I have sine theta squared, and I replace x with cosine theta, I have cosine theta squared, and that's equal to 1. So this Pythagorean identity, sine squared theta plus cosine squared theta, comes from the equation of the unit circle, which has a radius of 1, and I just replace y with sine theta and x with cosine theta. Tangent squared theta plus 1 equals secant squared theta. That follows immediately if you divide both sides of this equation over here by y squared. If I divide both sides of this equation here by y squared, then when I divide each of those terms in the numerator, excuse me, I misspoke. I'm dividing both sides by x squared. My bad, I apologize. I'm dividing both sides by x squared. When I divide each of these terms in the numerator by x squared, I end up with y squared over x squared plus 1 is equal to 1 over x squared. Well, y squared over x squared, right, is y over x quantity squared. That's equal to tangent squared. And 1 over x squared is 1 over x quantity squared, and that's equal to secant squared. So this identity follows from this one just by dividing both sides by x squared. And then we get this identity by dividing both sides of the equation of the circle with y squared. Okay? So the three Pythagorean identities, the one that I've remembered since I was 18 years old is sine squared plus cosine squared equals 1. Okay? And then the other two kind of follow from over here. Alrighty? All right. So that's the end of that. So those fundamental identities, again, have to be memorized for exam 1, along with all the other stuff you got to memorize. Okay? So we're going to pause right here, and in the next video, we'll start with this exercise right here. Okay?